Hi everybody, today what we're going to do is we're going to start with a tour of the periodic table, review some important concepts here. Then we're going to transition to this other packet that we've been working on. It's called 3.1 Ionic Compounds in Canvas. Here it's called Naming Ionic Compounds. We've already done a lot of work in this packet. We'll review some important concepts here, then we're going to get a little bit of structured practice. Okay, starting with some important concepts on the periodic table. Remember that groups are vertical columns. We've got this color-coded in black, so this is main group 1, main group 2, all the way up to main group 8. And the saying for groups is 1, 2, skip a few, 3, 4, 5, 6, 7, 8. Remember, the main group number tells you the number of valence electrons. That leads us into thinking about the charges, which I think you also have written on your periodic table. Charges are in red. So remember, for the 8 main groups, it's predictable what charges the elements are going to take. And the sequence goes +1, +2, skip a few, +3, typically plus or minus 4, -3, -2, -1, and 0. Okay, remember, the charges relate to the main group number because the charges for elements in the 8 main groups, they always want to gain or lose the fewest number of valence electrons possible to get to that stable octet of 8 valence electrons. So for that reason, it's predictable that elements in main group 2, which have 2 valence electrons, will lose 2 valence electrons to take a +2 charge, attaining a stable octet of 8 valence electrons. Likewise, for example, it's predictable that elements in main group 5, they've got 5 valence electrons, they want 8, they will gain 3 valence electrons so that they attain a stable octet of 8 valence electrons. So whereas main groups are vertical columns and we have 8 main groups on the periodic table, periods are horizontal rows. And remember, the period number, 1 through 7 down this side right here, tells you the number of energy levels in the Bohr atomic model. All right, we've also learned that metalloids divide the left and the right side of the periodic table. So we've got the metalloid stair-step line right here. Looks like there are about 8 metalloids on there. To the left of the metalloid stair-step line, we've got the metals, and to the right of the metalloid stair-step line, we've got the non-metals. We also learned that metals like to form positively charged ions. That's supported with this concept of the charges that are right over here. And we also learned that non-metals, they like to form negatively charged ions, which are called cations. And you can see negative charges over there for most of the non-metals. Last thing, we've also got these 3 oddball transition metals here that take fixed charges. So remember, silver takes a +1 charge, cadmium takes a +2 charge, and zinc takes a +2 charge. Okay, also note that there are a lot of similarities between the work that we've got on here and work that we've already done on this paper. For example, we get information about charges for elements in main groups 1 and 2, and for these anions that are right over here. Remember, the term cation means positively charged. Anion means negatively charged. We can see the metalloid stair-step line right here, so metals are to the left, non-metals are to the right. We also get some additional information about different metals that can take a variety of charges, multiple charges. So for example, you can see iron likes to be in the +2 or +3 state, nickel, same thing, copper +1 or +2. Mercury does this weird thing where 2 mercury atoms will bond together. That's what the subscript 2 means right here. And collectively, they take a +2 charge. Or you can have a single mercury that's not bonded to anything else, and it takes a +2 charge. Same kind of concepts over here with lead and tin. Remember that we also have 3 rules for ionic compounds. And I've got the rule number 1. I've got it color-coded in orange right here. They must be electrically balanced. We're going to talk about that in a second. You've always got to write the cation first, followed by the anion, and you've got to reduce the subscripts if possible. So again, rule number 1 says that ionic compounds have to be electrically balanced. Down here, we've got a similar statement, also color-coded in orange. It says, keep in mind that the sum of the charges in an ionic compound has to equal 0. So for that reason, since potassium ion always takes a +1 charge, we get that information right here. And since sulfide ion always takes a -2 charge, information is right there. Since the sum has to equal 0, we must need 2 potassium ions to 1 sulfide ion. So the ratio is 2 potassiums to 1 sulfide. So this is the formula here. And remember that iron can take 2 different charges right here. It's one of those unusual transition metals. And some of these right over here, they also like to take multiple charges. because it can take two charges of either +2 or +3, if iron in either of these charge states were to bond to sulfide ion, we would have a 1-to-1 ratio so that the sum of the charges equals 0. And for that reason, this form of iron sulfide would just be FeS. Or we can have different ratios because iron can also take a +3 charge. So here you've got to think about the LCM, the least common multiple. The LCM between 3 and 2 is 6, so we're going to need 2 iron ions, each in the +3 state, to balance out with 3 sulfide ions, each in the -2 state, so that the sum of those charges equals 0. So see how there is a 2-to-3 ratio of iron to sulfur. Okay, so let's get a little bit of practice right here. You can write this information down on a separate sheet of paper. You can see up at the top, I've restated those rules for ionic compounds. So remember, I think that rule number 1 is most important. And rule number 1 says that ionic compounds must be electrically balanced. Another way to say that we saw on the previous sheet was keep in mind that the sum of the charges for an ionic compound always has to equal 0. And that's this column right here, balanced charges. So for example, if we have calcium ion mixing with chloride ion, one thing that I like to do is to write the charges directly over each of the species right here. Okay, that kind of helps me to wrap my head around what's going on in this particular, writing this particular formula. So I'm going to write Ca2+, Cl1-, and remember the sum of those charges has to equal 0. So for that reason, we need to mix and match the calciums and the chlorides to get this to be a true mathematical statement. And so I'm going to put another chloride ion right there. We can now see that the sum of these charges equals 0, and therefore the formula is CaCl2. Okay, same kind of thing with aluminum sulfide. Aluminum likes to take a +3 charge. Sulfide ion likes to take a -2 charge. By the way, just as a reminder, we get that information from right here on the periodic table. Aluminum ion, +3, sulfide ion, -2. Remember, we've got to think about the least common multiple. In the least common multiple, the LCM between 3 and 2 is 6. So that means that I'm going to need 2 aluminum ions to equal +6, and we're going to need 3 sulfide ions to equal -6. And that's now a true mathematical statement. So the ratio is 2 aluminums to 3 sulfides. So that's the correct formula for aluminum sulfide. All right, for magnesium and phosphorus, magnesium phosphide, it's going to be +2, -3. Again, least common multiple of 6. So I'm going to see that we need 3 magnesium ions to 2 phosphide ions, and see how this is +6, this is -6, the sum of those charges equals 0. So the formula is Mg3P2. Now, it's a little bit more challenging to go from a name over to a formula. It's a little bit easier to go from the formula backwards to the name. Okay, let's practice it with this set that we've already done up here. If you mix magnesium and phosphorus, it's not called magnesium phosphorus, it's called magnesium phosphide. Okay, so see how what you do is you drop the ending of the anion and you add the suffix IDE. So for this one, it's not aluminum sulfur, it's aluminum sulfide. For this one, it's not calcium chlorine, it's calcium chloride. For this, it's not sodium sulfur, it's sodium sulfide. For this, it's not magnesium nitrogen, it's magnesium nitride. And for this, it's not gallium oxygen, it's gallium oxide. Okay, so remember, you just drop the ending and add IDE for the anion. All right, thanks a lot, guys. You're going to have a little bit of structured practice on this. Your job after doing the structured practice in the ed puzzle is going to be to go back to this packet and to complete 16 through 21. If you feel confident after that, you can also address question 22. That's a separate assignment in Canvas. And you're also going to find that you have multiple practice assignments that are up on Canvas already. They're all called 3.1 practice ionic compounds 1, 2, and then shortly you're going to have 3, 4, and 5 up there. All right, thanks a lot, guys. Have a good day.